Hey everyone, welcome back to my YouTube channel. In this particular video, we'll be proceeding with our project Heart Disease Prediction using machine learning. In the previous video, we already have seen the different visualization graph of that particular data set. We have compared a lot of different columns with each other and we have seen different insights of that particular data set. We have deeply studied what exactly that data set was including inside it, what was included in that particular data set, and we have studied the different variations as well as proportions of the columns with each other. I hope you have watched that particular video. If you haven't watched that particular video, so I'll recommend you to watch it first and then come to this particular video. In this particular video, we'll be specifically doing the modeling of our data set, which is going to classify correctly whether the patient is having heart disease or not based on the values that are provided as an input. So first, we are going to split the data set into training as well as testing. So I hope you know that training means that particular set of data which is going to be fed into the model for making it learn the different insights or the patterns that are present inside the data. So we are going to provide 80% of the data as training data set so that the model is going to train 80% of the data set that is present in our entire data set. Next, in testing data set, we are going to keep 20% of the proportion of the entire data set. So I'm going to import sklearn.model selection. From that, I'm going to import train test split. This particular library is used for splitting the data set into train as well as test. So here are the parameters: extreme, xtest, ytrain, and ytest. As you know, extreme is the data which contains the features of the training data set. Xtest is the data which contains the features of the testing data set. Ytrain is the data which contains the label whether the patient is having heart disease or not. That particular label column will be present for the training features. And in ytest, the testing labels will be present. Now we are going to call this particular module train test split, inside which we'll pass some of the parameters. First is the feature columns. So basically in our data set, if you remember, the last column was the target column, that is the heart disease column. So we are going to drop that particular column from the heart underscore df dataset and we are going to keep all the other columns as features. The next parameter will be the target column, which is the heart disease column. So this is going to be the label column. Next, we are going to provide the test size, which is used with the variable test underscore size equals to zero point 0.2. Now this means that 20% of our dataset will be used for testing purpose. Next, we'll define a random state, which is set as 42. You can initialize it with any number. Next, I'm going to provide this particular parameter stratify equals to. Now, the usage of this particular parameter is that it is going to split the data set in such a way that the training as well as the testing set will contain the same proportion of the label classes which are present in the entire data set. For example, if our entire data set contains 40% of labels which are 1 and 60% of labels which are 0. So our training set as well as the testing set will also contain 40% of the records which will have the label as 1 and 60% of the records which will have the label as 0. So this is what is the use of stratify. And we are going to provide the target column as the column through which it is going to split it into that particular amount of proportion. So I hope this particular step is clear to you all. I have executed this particular cell and it has got executed successfully. Now we'll try to train our model. So for training model, as we already have discussed, we are going to use four different algorithms. The first algorithm is logistic regression. Now, why we are using logistic regression? Because logistic regression is used for binary classification. In our data set, there are two classes in the target column. So this data set is fit for binary classification purpose. Now, for training the model, we are going to use a list of solvers which are supporting the logistic regression. Now, here I've imported logistic regression model from sklearn.linear model, and after that I have imported accuracy score from sklearn.metrics to evaluate the performance of our model. Here I have defined a list solver equals to, and then I have listed all the solvers which are present inside logistic regression. You can get this list of solvers from the documentation of logistic regression. As per your convenience, you can cut or add the solvers. Next, I'm going to define a string which is going to be which is going to store the best solver name. So obviously, every single solver is not going to give the best results. Among this, only one solver is going to give the best result, and the name of that particular solver will be stored in this particular variable best underscore solver. Next, I'm going to define an array of 6 elements. Now over here, you can see it is going to store the testing scores. That means the performance of every single solver which we are using here. You can see over here we have 6 solvers. So that is where 6 total accuracies will be present, and that accuracies is going to be stored in this particular array which I have initialized with np.zeros. So this np.zeros is going to create an array of 6 elements, all with the value 0. So it will look something like this. Now, as you know, we are going to use more than one solvers. So for that, we are going to use a for loop. So for I, comma n in enumerate of solver, here inside the enumerate function, we are going to put the solver variable. So basically, enumerate function will just try to iterate over every single solver elements, and it is also going to keep a track of the index of each and every solver. For example, if the control is here at the index 0, so inside the variable I, the index value will be stored, that is I will be equal to 0, and then n will be equal to the name of the solver, that is LBFGS. Similarly, in the next iteration, the solver will be liblinear. So the n value will be liblinear, and then I value will be the index at which this liblinear name is present, that is 1. Now, what we are going to do, we are going to create an instance of this particular logistic regression module. Inside this, we are going to pass solver name. Now, obviously, the solver is actually present inside the temporary variable n, which is going to be different in every single iteration. So solver equals to n, and then we are going to fit that model training set for training our model, and we are going to store that particular model in the LR variable. For this particular iteration, we are going to look for this solver LBFGS, and for now, the solver is LBFGS, and this solver is going to store, and using this solver, whatever model will be created, it will be stored inside the variable LR. Next, once the model is created, we are going to use the score function inside this particular model to evaluate the results. So for evaluation, we are not going to use the training set. We are going to use the testing set. So this x underscore test is the testing features, and y underscore test is the testing labels. So we are going to pass these two, and this is going to create the accuracy score for this particular model, that is for this particular solver, and it is going to be stored inside the test underscore score variable at the index at which that particular solver is present. So this particular solver is present at 0th location. As you know, the I variable also contains the 0th location. So let's say here you can see I already told you what is going to be the output of this particular step, that is np.zeros with 6 elements. So at for iteration 1, you can see at 0th location we are getting this particular score. So at 0th location, that particular accuracy score will be stored, something like this. So once this is stored, next step is that we are going to find out the maximum score out of the list that is going to be created in this test underscore score variable. So we are going to check if lr.score of this current instance, that is x test and y test, is actually the maximum of the list that is actually created. If it is maximum, then that is actually the best solver because its accuracy is maximum. So we will say that the best solver is nothing but the name of the solver, which is stored inside the variable n, which will be stored now inside the variable best underscore solver. Now, once this for loop is done, we will be getting our best solver. That is the name of the solver from this particular list. And once we get the best solver, we will then use this particular statement to get our best model. That is, will be stored in the variable LR. Now we'll fit LR.fit the training data set, and then we are going to predict on the testing features by passing this x underscore test variable in the predict function, and we'll store it in the variable LR underscore predict. And just to check the accuracy score, we are going to pass the y underscore test, that is actually the testing labels. We are going to pass this in the function accuracy score, which is going to evaluate the accuracy score of that particular best solver model. So let's execute this. You can see over here we have got the accuracy of 85%. This was for the best solver. So from all this best solver, which is the best solver? Let's try to print it. So let's execute it. You can see the best solver is this Newton-Cholsky, and this is giving us the accuracy 0.8586. That is nothing but 85.86 percentage. So it's not a bad accuracy. When we talk about the size of our data set, when we consider it, this particular accuracy is actually good. So now I hope the logistic regression part is clear. Now we'll do the same thing for different types of algorithms that we have used in this particular project. So now let's move on to the next algorithm, which is support vector machine. Now, since this particular problem is a binary classification problem, we are going to import SVC, that is support vector classifier, from the sklearn.svm model. And we're also going to import the F1 score as performance evaluation matrix from the sklearn.metrics module. Now, as we have seen that inside this logistic regression, we had the solvers. Inside the support vector machine, we have these kernels. So basically, kernels are nothing but mathematical functions which will manipulate the data. Now, here we are going to use four different kernels: linear, polynomial, RBF, and sigmoid kernel. We'll check which is the best kernel according to the accuracy that it gives. And you can see that we have initialized a dictionary over here with the key as the kernel name and the values as 0 for now, because here instead of zeros, we are going to store the accuracy that this particular kernel is going to give. We also have initialized a variable best, which will store the name of the kernel, which is giving us the best result, that is the maximum accuracy. Now, again, since we are going to use more than one kernels, we are going to iterate using for loop. So for I in kernels, first we are going to create an instance of this particular SVC classifier with that particular kernel. So kernel equals to I. So once this instance is created, we are going to fit the training data set with this particular SVM model. So svm.fit xtrain, ytrain. Next, y hat variable is initialized, which is going to store the prediction results of the features that are present inside the testing dataset. So xtest is going to be passed inside the predict function of this model, and this is going to evaluate the array of predictions which will be stored inside the y hat variable. Now, once this is created, we are going to calculate the F1 score, that is the accuracy score of the Y test, that is the testing labels with Y hat, that is nothing but the prediction of the testing data set. And we are going to initialize average equals to weighted. So this particular score is going to be stored inside the value part of that particular key, which we are currently working on. And then we are going to check whichever is the maximum of all this, and whichever is the maximum, it is going to be stored inside the best variable. Now, after this, let's also try to print this best variable value, and then this best variable value is already containing the best kernel. So we'll now use the SVC classifier with this particular best kernel, and we'll try to fit the data, and then we are going to predict it. After that, as usual, we are going to calculate the accuracy with this by test data and the prediction data. So So if we try to execute this particular cell, it takes a little time, and you can see linear is the best kernel over here. And if we talk about the results, we are getting 0.84, that is nothing but 84% accuracy. 84.22% is the accuracy for this particular SVC classifier, out of which the linear kernel is the best performer. So that's all about the support vector machines. So now let's move on to the next classifier, which is decision tree classifier. So speciality of this is that I'm going to use grid search CV. So basically grid search CV is going to be helpful to carry out all possible iterations, all possible combinations of all the hyperparameters that we are going to provide for our model. So basically over here you can see we have max depth, minimum sample split as a form of list. You can see there are a lot of values. So what this grid search CV is going to do is going to create all possible combinations. For example, in the first case, it is going to take the 3 as the max depth. Then it is going to take the minimum sample split as 2, then minimum sample leaf as 1, then random state as 0. So this will be the first combination, and it is going to solve it with this particular parameters. So like that, all possible combinations will be created for every single parameter which is present inside all the lists. So whichever set of parameters is actually performing well, or I would say is actually performing the best, will be selected as the best model. So here you can see we have initialized a variable decision tree classifier, which is nothing but an instance of the decision tree classifier class. So we are going to now use the grid search CV. Inside this grid search CV, we are going to pass the model name, that is decision tree classifier, and then the parameters grid. Now here I am also providing cross validation parameter as 5. Now this is going to be stored inside the grid search variable. Now as usual, we are going to fit this particular training dataset, and then once till this step is done, we'll be getting the best parameter list. We'll be getting the best parameter combination. And once we get it, we can use this particular keyworded argument, that is grid search. So basically inside this grid search, whichever is the best set of parameters, we can access it with this particular best underscore params underscore from this particular grid search. And we'll be storing the best decision tree model with the best parameter list. And after that, we can just, as usual, fit this particular training dataset, and then we can, as usual, find out the accuracy of this testing dataset. So let's try to execute this particular cell and see what output we get. So here you can see cell is executing, and you can see that we have got the accuracy of 80.97% for this decision tree. We can also alter this particular set of parameter and try to get the best result. So now let's move on to the next classifier, which is random forest classifier. So here you can see I'm again using grid search CV, and this time we are going to use the random forest classifier. I have created an instance of this particular random forest classifier, and I have stored it in the variable RFC. Next, I have defined the parameters grid. Here, there are total 4 hyperparameters, which is n estimators, max features, max depth, max leaf nodes. Here, there are a lot of other parameters also that are present inside the random forest documentation. You can check it in the official documentation. If you don't get it, then just comment down. I'll share the link. Then comes the list of all the possible values that can be for this for every single hyperparameter. So you can see I have listed this particular set of values. You can also alter this particular values as per your expertise or as per your research. You can try different variations in this and try to get the best results. So now again, as usual, grid search CV model will be called, and inside this we are going to pass the random forest classifier with the parameters grid, which is this particular dictionary. This is going to create a model with the best hyperparameter set. Will store inside the variable grid underscore search. Then we are going to fit the training data set in this particular grid underscore search model. By executing this, we will get the list of best parameters, and we can store it in the and we can store that particular model which is trained with that particular best parameters in the variable RFC tree, and then we can again fit this particular training set in with this particular model RFC3. Predict the testing labels with this particular testing features, and we can store it in the variable RFC underscore pred, and then we can calculate the accuracy score with this y-test and then RFC pred. So let's execute this particular cell and let's see what output we get. So here you can see that we have already got the results, that is 82.06 percentage. So this is the result of the best set of parameters that has got selected from the list of parameters that we have defined. You can also alter this particular set of parameters and you may get better results also. You can try your own set of algorithms and you can get better results also. I have tried only 4 algorithms. You can try more and you may try to alter this set of parameters and you will get better results. So I hope the data modeling part is clear to you all. Now we have created this particular 4 models. We can use any of the feature values and we can get the prediction results from all these models. So we are going to integrate all these models in our website that we are going to build in the next video. And in that, we'll try to add different features and different functionalities, which is going to be very helpful when it comes to single or bulk prediction. So stay tuned for that. And if you like this particular video, please like, share, and subscribe to my channel. Also hit the bell icon. And don't forget to follow me on Instagram. Please join me on Telegram. And thanks for watching. Have a good day ahead.